All right, so here's the rest of that table all filled out. Now, notice what I'm saying here. So for example, look at this one. If you've got 95% in the middle, that means that there's 5% in the tails because they're complements of each other, right? And then you cut the tails in half, and that gives you 0.025 in each tail, and that's what you can use with norm inverse in order to find 1.96. You could either use 0.025 and then just make it positive, or you can use 0.975, which is the complement of 0.025. Either way. And then I did it again for 99%, because if it's 99%, then 1% is the alpha, which is the complement. And then you cut it in half to get you 0.005, and that's what you can use for norm inverse, making sure to type in 0 and 1, and you get 2.576. All right, now keep these three in mind. These three we're going to use a lot, and I'm not going to show you how to do them every time. You're just going to know them. But of course, you should be able to find them on your own if you had to. Okay, so in class, we wanted to know the true proportion of all red beans in the box. Suppose you reached into your scoop and got 30 red beans and 90 white beans, blah, blah. In order to construct a confidence interval, it must be the case that n times p times 1 minus p is greater than 10 and n is less than or equal to 0.05 capital N. Verify that these hold true. All right, now you didn't get to see it, but I already made a video and it got eaten by my computer, so I'm just not going to re-delete this, so bear with me. So first of all, little n, is your size of your scoop, the size of your sample, the number of people you actually call on the phone or whatever. Capital N is the population size, right? The number of people that are interested in it altogether in the whole planet or whatever. So for our case, because our scoop was really small, it was like smaller than a Dixie cup, and our box is full of beads. And it's a good sized box. This is not, a couple inches by a couple inches. This is, a foot and a half long by a foot wide or whatever. Because that's the case, 120 is definitely less than 5% of it. Now, I know I'm kind of waving my hands at that a little bit like a magic trick, but you get to do that sometimes. If they give you a capital N in the problem, like there are 30,000 people in the population or in the city or whatever, well, then you can find what 5% of 30,000 is and make sure that 120 was less than that. But most of the time, you're not going to be taking a large enough sample for it to bother with, right? So it's a little magic tricky, ta-da, but that's kind of how it is. And again, if they give you a capital N, then by all means use it. But we don't have a capital N here, and I'm not going to count every bead in that box, trust me. All right, then you want to check that n times p times 1 minus p is greater than 10. And I did that with Excel right here. Oops, right there. 120 times 0.25 times 1 minus 0.25, and it makes 22.5, which is indeed larger than 10. That ensures that the data is normal. Well, it ensures that the sampling distribution of sample proportions approximates a normal distribution, if you want to get technical about it. But suffice to say that we get to use the normal distribution. Now, down here, they want us to construct the interval for the true proportion of red beads based on our sample. Show the formula substitution in the final answer using the computer. Oopsie. So for these kind of things, you don't have to do this formula by hand, longhand. If you really want to, you can type it into Excel. So there's a lot of ways you can do this. You could literally just type equals 0.25. Well, you know what? Let me make a mess by myself. Let me label some things here. P hat is 0.25. N was 120, right? And our Z was 1.96. Okay, so if you want the lower bound, I'm just going to use some cell referencing here. I want 0.25 lower bound, minus 1.96 times SQRT, big square root, of 0.25 times parentheses 1 minus 0.25 divided by that n. Enter. There's the lower bound. And then for the upper bound, hold on, I gotta pause because I'm running out of time. There we go. It's the same formula, but with a plus sign right there instead of a minus sign. But other than that, it's the same. And I didn't drag to make it. I retyped it because otherwise the cell referencing wouldn't work. Notice, by the way, that's 17 and 32, just like we talked about at the beginning of the section.